We live in one galaxy, the Milky Way galaxy, but there are probably millions, if not billions, of other galaxies within our universe. So we need to be able to define what types of galaxies we see throughout. So for a galaxy, this is going to be all of our interstellar matter. All of our solids, all of our gases, all of our liquids, the stars, the stellar remains, everything that's gravitationally bound to a central point. And we're going to see that there are three basic types of galaxies within our universe. We're going to have spiral galaxies, elliptical galaxies, and irregular galaxies. Our galaxy, the Milky Way, is a spiral galaxy. This is one where we have a centermost area that's called the nucleus, and then we have arms that are spiraling outwards from the nucleus. For me, this looks a lot like a hurricane whenever we're watching out during hurricane season on the map. But these spiral galaxies are very large. They're generally up to about 125,000 light years across. And these spiral galaxies are going to contain both young and old stars. Our other two types of galaxies have very different shapes and ages, though. Our elliptical galaxy is shown here in the upper image. These have an ellipsoid shape. They're kind of oval. I think of them as football-shaped. And most of them are going to be smaller in size than our spiral galaxies. And when they're small in size, we just call these dwarf galaxies. But to make it complicated, the largest galaxies that we've ever discovered have also been elliptical galaxies. So we see that more often than not, these elliptical galaxies are very small, and we call them dwarf galaxies. But at the same time, some of the largest galaxies we've ever discovered are elliptical in shape as well. And then the third type is called an irregular galaxy. This one doesn't have any set shape to it. It lacks symmetry. And it makes up about a quarter of all the galaxies that we've discovered so far. But what makes these irregular galaxies unique, other than their lack of shape, is the fact that they contain almost entirely young stars. You don't find very many old stars in an irregular galaxy. When we look at galaxies, though, they're usually not just random and by themselves. Instead, they're usually clustered together in groups. And sometimes a cluster of galaxies can be thousands of galaxies in close location to one another. So we want to break these clusters into small groups and larger groups. A smaller group is called a local group. It's going to be those galaxies that are nearby each other. And in our local group around the Milky Way, there are more than 40 different galaxies that make us up. We're all just local to one another. But even though we've found 40 so far, there are probably many more undiscovered small dwarf galaxies in our local group as well. But we also want to look at a larger scale. Our local group is just going to be what's nearby. We also have what are called superclusters. And this is where we're going to have thousands of galaxies together. And they could be the largest entity in our entire universe. When we have these galaxies clustered together, they don't just sit there. We see a lot of the times that the galaxies can actually collide together. And depending on the size, we generally see that a larger galaxy typically swallows an entire dwarf satellite galaxy. But if we have two galaxies that are close in size and mass, they can simply move through each other without combining. For me, I kind of think of it as a ghost just moving through a material. But way into the future of our galaxy, in the next 2 to 4 billion years, there's a 50% chance that our galaxy, the Milky Way, will combine with our next door neighbor, the Andromeda galaxy, and will merge into an even larger galaxy.